So today these notes that we are taking, we're going to be reviewing over sections 7.1 to 7.3 for our quiz coming up on Monday. The first thing it says here is describe the likelihood of each event. So a lot of times what you really want to be looking for are keywords within the instructions. What do you think one of the keywords is that's going to help us with these instructions today? That's a good one. What's another one? Likelihood. I want everyone to take their red pen and draw a little cloud around likelihood, okay? So for likelihood, we're looking for actual words that we're going to write down. The first one says the probability that an apple tree will produce grapes is 0%. Jalen, what's the likelihood that something's going to happen if it's 0%? Impossible. It is impossible. How many of you would say that is what you wrote already? Okay? It's not going to happen. If there's a 0% chance, it's impossible. Let's go to the next one, Einar. The probability that a cat will give birth to a boy or a girl is 50%. What is the likelihood that's going to happen?
It's equally likely to happen or not to happen.
That is correct. Those are the words I want you to write down. So if you wrote something a little bit different, I want you to erase it and fix it. You are going to write in equally likely to happen or not happen. How many of you remembered that? How many of you were able to find it when you went back and glanced through your notes? Okay, excellent. So your notes in 7.1 that we had written have these exact words. There was a little chart. Anytime something's a 50-50 chance, it's equally likely to happen or not happen. Noah, the next one. C, there's a 15% chance of rain tomorrow. What's the likelihood it's going to rain?
Unlikely.
It is unlikely, okay? Probably not going to happen. It could, but it's a very small chance that it would. There's another one. If something was 100%, what's the likelihood of that?
Certain.
It is certain. Very good. Then if something is like 90%, what would that likelihood be? That is likely. You could even say highly likely because it probably would happen. Okay? So that's all we have there that's going to help us with the likelihood of figuring out an event. Let's look at the next one. Write the formula. On our last quiz and test that we had, there were a lot of formulas. For this one, there's only two. Theoretical probability and experimental probability. Who could tell me what the theoretical probability would be? Amira, what is it? Favorable divided by total. Okay, so you're going to take the favorable outcomes divided by the total outcomes. If you did not get that, go ahead and put it in a red pen. If you did, maybe just put a star next to it with your red pen or something to let you know this is important, okay? And experimental probability is another one that we need to know. Who could tell me what that definition is? Reese.
Experimental, success over trial.
You are correct, okay? Success is divided by the trials, okay? So the number of times you were successful divided by the total number of times that you tried it out.
So I'll erase it.
For this one, it says find the theoretical probability of the event and round it to the nearest 10th percent. I want you guys to take your red pen and put a little cloud around the 10th percent, okay? So this is something that gives you a clue. That's the kind of answer I'm looking for, rounded to the nearest 10th percent. When finding theoretical probability, what is our formula, class? Okay, favorable divided by the total. Now, if you remember, favorable is just simply what you're looking for. What are we looking for on problem A?
A 4.
A 4. Look at that spinner I have down there in the corner. How many 4s do you see there? 1. So that's the favorable outcomes. I can only see 1 4. So that's 1 out of how many total numbers? 6. Okay, so each time we see something like this, we're going to change it to a decimal. What is 1/6 as a decimal?
It's 0.16666.
Okay, very good. So the 6s are repeating quite a few times. Now, I want to change that over to a percent. How do I change that to a percent, guys?
Move it over to the right.
Move it to the right 2 times, leaving us with 16.66 many times repeating percent. Now, it asked me to round it to the nearest 10th percent. What would that be, guys? Okay, listen, the whole number is going to ask that 10th place, or the 10th place asks the ones next to it. Are you 5 or bigger? What's the 6 say?
Yep.
Yes, so that turns 16.6 into
17.
16.7. Okay, remember, once again, I'm looking for 10th percent, which means you must have a number in the 10th place like that right there. Okay, so be careful with that rounding. Remember, if it's asking for a whole percent, you want a whole number. If it asks for the 10th percent, you want a number in the 10th place. Okay, Let's look at problem B. Once again, theoretical probability. Gavin, what is the formula for theoretical probability? Very good. We're going to take the favorable, the thing we're looking for, divided by the total. What are we looking for on this problem, class? Spinning an even number. Hayden, how many even numbers do you see on my spinner? 3 out of how many?
6.
Out of 6. Guys, 3/6. What would that be as a percent? 50%. Okay, 3/6 can be reduced down to a half, and 1/2 is always going to be 50% chance. Doesn't that make sense? If I look at the spinner down here, I can see there's half even numbers and half odd numbers. So there's a 50% chance that I'm going to be able to get an even number. For number 4, it says to find the experimental probability of the event and round to the nearest whole percent. So we're doing experimental probability because they already did the experiment and they got these results. The first thing I'd like you to do is take your red pen and just draw a little cloud around whole percent. So the instructions are different this time. Okay, you always want to be looking to see what are the instructions asking. I'm going to be rounding it to the nearest whole percent. Hope, what is the formula for experimental probability? Very good. We're going to take how many times we were successful in what we wanted to get and divide it by the total number of trials or times that we did the experiment. Braden, how many times did this person successfully spin a 1? 41. Good job. So that's 41 out of, guys, how many trials did they have?
200.
200. How'd you get that? All right, you look down here and you add up the 1, 2, 3, 4, and 5. When you add all of those together, you are correct. You do get 200. Isaac, what's 41 divided by 200?
0.22. In other words, it's 22%.
No, not 22%. You're close. Huang, what'd you get?
I got 21%.
Okay, so if I have it out as a decimal, it comes out as 0.205, right? So that would be 20.5%. And what Huang just told us is he rounded it, okay? He saw that it needs to round up, so the correct answer would be 21%. All right, let's look at problem B. It's very similar. Once again, we're still using the same spinning information that we got from the experiment. Let's start with the formula. Braden, what's the formula for experimental probability? Good job. We're going to take how many times we were successful divided by the total number of trials. Guys, looking at my graph down here, which numbers were odd numbers?
3 of them.
1, 3, and 5. Okay, the numbers on my actual spinner, 1, 3, and 5, are odd numbers. Add those 3 numbers together, and how many successful times did they land on a 1, 3, or a 5? 120 times. Okay, I have a few faces that look confused. Remember, we are trying to figure out which numbers they landed on that were odd numbers. Okay, so you're actually looking down here. This number 1 is odd, number 3 is odd, and number 5 is odd. Okay, so then you take your results from those numbers. Out of, how many trials did they have? Out of 200. Okay, Amira, what's our percentage here? Okay, you get 0.6. Move that over, and your percentage would be 60% is correct. Okay, here's what the instructions say. Use the fundamental counting principle to find the total number of possible outcomes. What method are we using to find this? There you go, fundamental counting principle. This we talked about yesterday. It was an easier way of doing something than that tree diagram, which took us kind of a while. What key thing do I have to remember to do when using the fundamental counting principle?
Multiply all the numbers.
Multiply. Okay, we just got to remember to multiply them together. So problem A says, how many different outfits can you make from 7 shirts, 5 dress pants, and 2 pairs of shoes? Hayden, what do you think I have to do with this? Excellent. 7 times 5 times 2. Now, even without using a calculator, okay, you can do 2 times 5, which is 10 times 7, which is 70. And very simply, without using a calculator, you figured out, and remember, units should be attached, that there are 70 different outfits you could make from that problem. You choose between blue or pink paper and green, purple, black, or white markers. How many possible outcomes are there when you select one piece of paper and one marker? Guys, what are the options of paper? 2 of them. Blue or pink, okay? So I'm gonna put a 2 because that's all I have options for paper. How about the markers? How many options are there? 4 of them, okay? I could get green, purple, black, or white. What should I do to those two numbers? Multiply it together, okay? So the answer is 8. And what are the units attached? All right, possible outcomes. I like it. Once again, the question, if I go back to my original problem, does ask me right here how many possible outcomes, okay? So that would be good units to attach to it because it came straight from the question. How many of you were able to get that on your own? Okay, very good. Let's move on to number 6. Number 6 says to find the probability of the compound event and round to the nearest whole percent. I want you to take your red pen, if you would please, and just draw a cloud around rounding to the nearest whole percent. Now this says that we're going to be doing a compound event. What does that mean? More than one, okay? So 2 or more. So that's what we want to be looking for. This says that we are going to roll a number on a number cube and flip a coin. What is the probability of rolling a number greater than 3 and flipping heads? So the first thing I want you to do is write down that formula. Favorable divided by the total. Okay, this is going to help us to find it. Now there's 2 events I'm looking for. What's the first event I want to find? Rolling a number greater than 3. Underline that for me. Okay, so we know that's what we're looking for first. Once again, compound event means there's going to be 2 things I'm multiplying together. What's the second event? Flipping heads. Underline that one. Now, let's think about a number cube. How many numbers on a number cube are favorable for being greater than 3? 3 numbers. What are those 3 numbers? 4, 5, and 6. Okay, out of total, how many total numbers are there? Out of 6. Okay, now, am I done? No. No, there's a second event there. Flipping heads. How many heads are on a coin?
1.
Out of 2. What should I do to those 2 numbers? Multiply it across. What's 3 times 1?
3.
What's 6 times 2?
12.
Can that be reduced?
Yes.
To what?
1.
1/4. What percentage is 1/4? 25% is correct. For problem B, you roll a number cube and you spin the spinner. What's the probability of rolling a number less than 4 and spinning a number higher than 4? So I want you guys to underline with your pencil the first thing we're looking for, rolling a number less than a 4. What's the second thing we're looking for? Spinning a number higher than 4. Okay, now let's start with our formula. What's the formula, guys? Favorable divided by the total. Rolling a number less than a 4. How many numbers are on here that are less than a 4? 3 out of 6. Next one, spinning a number higher than 4. Looking at this, the same spinner I have in my hand right here. How many numbers are on here that are higher than 4? Gavin, what is it? Only 1. What number is that? A 5. Is a 4 higher than 4? No, it's equal to it. So I have a 1 out of 5 chance. What should I do to those 2? Good job. Since it's a compound event, we multiply them together. 3 times 1 is? 3. And 6 times 5? 30. Can that reduce? What would that be reduced? 1/10. What percentage is 1/10? 10%, okay? There is a 10% chance, guys. This is even less likely to happen than our last one. Okay, there will be some review problems on your quiz coming up. It says to use the percent equation to solve. 48 is 75% of what number? Guys, what is the percent equation? P times of equals is. Now, there's something that I always ask you to do to the original problem. What is it? Underline it and circle it. We're trying to find the is, the of, and the P. What should I underline? What should I circle? What should I underline? All right, I want you guys to try it on your own. All right, Jalen, what should I do to my percent?
The percent?
Change it to a decimal. What would it be changed to a decimal? So if you see that it says 75%, change that to a decimal, and what do you get?
I got .64.
No, what's the percent changed to a decimal?
Oh, 75.
Okay, so if I have 75% changed to a decimal, what would it be? 0.75. Gavin, what's my of? X. Trenton, what's my is?
48.
48. Hayden, how do I get the X by itself?
Divided by 0.75.
Very good. Huang, what do we get for the answer?
6x equals 64.
Okay, guys, is this 64%?
No,
Why not?
because it says up number.
Okay, if I go back up here, it says of what number, so I want to keep it as a number, so the correct answer is 64. The final problem for today says to find the selling price. The original price was $30 and there's a discount of 10%. I want you guys to try this one on your own. If you are looking for a formula, you can use P times of equals is. Okay, so for this problem, there's a couple different ways you can do it. This is one way that I saw a lot of people had done it. They changed that percent to a decimal, 0.1, multiplied it by the total, $30, and for their is, they got $3. Now, is $3 the answer? What is that?
What's it called thing?
That's the discount, so that's $3 off. What was the original price?
$30.
$30. So what should I do to the discount?
Minus.
Subtracted. So what's the answer?
27.
How many of you would say you did it that way? Who would say that you did it a different way? Remember, there's another way that I said you could do it. Normally, the thing costs 100% of the price, but there's a 10% discount that they're taking off. So what percentage are you actually paying? If it was 100%, but you're getting 10% off, what percentage are you paying? You are paying 90%. So we would turn that 0.9 times the dollar amount. Guys, what's 0.9 times $30?
27.
27. So it depends on how you would prefer to do it. I am okay with you doing it either way, okay?
That was super easy.
I do think that this way is a little bit easier because it's all done in one step, but sometimes people forget to change it to that, okay? So just remember, guys, use these notes to help you to study for your quiz coming up on Monday. It's 7-1 to 7-3.